So let's try showing 3 groups of 12 with the base 10 blocks. So again, the standard interpretation of this right here would be 3 groups of 12. Grab my virtual base 10 blocks and make 1 group of 12. Another group of 12. And another group of 12. Oops. And we can pretty easily count the base 10 blocks we have here. We can easily see that we have 3 10s and 6 1s, so the answer ought to be 36. All right, so same thing we were doing with the simpler 2-digit numbers. The more interesting thing happens when you start multiplying slightly bigger numbers. Like, instead of 3 times 12, what if we did 13 times 12? 13 groups of 12. Now, before I start drawing that, I just want to pause for a minute and think, what other models did we have besides groups of? What were the other models we had for multiplication besides groups of or repeated addition? So that's kind of what I'm showing here.
Area.
I have the sets or the area. So I want to think about this as an area. So if I think about an area, when I do area, I think of one number as the base and the other number as the height. And I want to use the base 10 blocks help me outline an area that is 13 by 12. Now, and then I'm going to fill it in. So let's try to do that. Actually, I think I want to do it on paper first and then play with the blocks. So base of 13. So I have to use one of those blocks to measure out what 13 would look like. So let's say that's about how long a 10 is. And then I want to go, that would be about 1, 2, 3 from there. So there's my 13 across the bottom. And then I want to measure up from there. I'm just going to use a different color. Oops, straight line would be nice. How about that right there, maybe? And then 1, 2. The best of my artistic ability today. So I want to fill in this area with base 10 blocks. Just put it up there. So would you agree that thinking about the way base 10 blocks were, 12 is really 10 plus 2? And 13 is really 10 plus 3. So doesn't it make sense to kind of block off the 1s and the 10s in this picture here? Because then I can use a flat here instead of a whole bunch of 10s. And then otherwise, I can just split off the 1s here like this. So what I like you to do is get out your base 10 blocks and build this shape with the base 10 blocks. So I'm going to go use my blocks to try and reconstruct my drawing to justify the answer. And then I'll write my answer down. So let's see, I'm going to blow up those guys. Actually, I could keep some of them. You can go, you could go, you can go. Oh no, I wanted those guys. Can't do here, can I? Those guys over. So then I'm going to have, so here's my 13 across the bottom, right? 10, 1, 2, 3. And then slide those guys up there. And I think I got my picture constructed. So hopefully you made a similar thing with your blocks on your paper. So what do we see here? For sure, there's a 100 in there, right? And how many tens? 1, 2, 3, 4, 5 tens. So there's 50. And then I have this nice group of 2 by 3, which is 6. So it looks like the answer is 156 from the picture, which is kind of nice. So kids can grab the blocks, think about area and base 10, and kind of throw the answer together. So again, when I look at this picture right here, starting here at the bottom, I see a 10 by 10 area or a 100. I see 3 tens or 30 there. I see 2 tens, 20 there, and I see this 2 by 3 area here, which is 6. So my answer is 100 plus 30 plus 20 plus 6, which is 156. So this right here is the result of multiplying 12 by 13. Didn't we do something like that with addition before? Remember that? Expanded addition? So from the picture, I can get this expanded multiplication algorithm. All right, let's try another one of these. In particular, let's take a look at the activity and do one of those. So again, we're considering groups of, in more particular, the area model where we have a base and a height. And here I give an example of 23 by 12. And from that, I can see the yellow region is 200. And then I have a group of 30 and a group of 40. And so down here, I'm illustrating those out, and finally a group of 6. And putting it all together, there's 276 individual items in this area. And then do I have a typo down here? I do have a typo. Oops, I'll fix that in a minute. We're going to skip down to problem number B here. You can go back and do A in a moment. I want you to illustrate with the base 10 blocks 15 times 13. I'm going to do it too. And I'm going to sketch it first, and then I'm going to build out the blocks. You can do it in either order. $15 times 13 is what we want to show. And usually I like the first number to be the base, but it's not super important. All right, so let's say that's about 10, 11, 12, 13, 14, 15. That's 10 across the bottom. 10 vertical. And again, since we're using base 10 blocks, it makes sense to break off the tens and then the ones. And after I do that, I should have a pretty good illustration of base 10 blocks. right, so somehow the answer lives in there. I'm gonna make the same thing with my toys just for fun. So this one is going to be 15. 12, 13, 14, 15 by 13. Oh, try illustrate here. So the Math Learning Center app does have a pen. Color is blue. That should work. So I see 100 there. 50 over here. And I see 30 there. Then I see 15 over here. So stacking those, starting at the 100 row, I have 100, and I have 50. Oops. Ooh, can't undo. Erase. There, 50, 30, 15. Now, the 15 is a little tricky because isn't a 15 a 10 and a 5? So really in this illustration, I should make a note to get the actual answer. I need to trade 10 ones for 1 10. That up here. And that's how the 1 10 ends up in that column right there, stacked, the way we like to group numbers.
On our illustration, should we note exchanges like that?
You should note exchanges like that. Yep. That's specifically why I wanted to do this example with y'all. So there's going to be 5 ones. Do I have enough 10s to exchange? 5, 6, 7, 8, 9. Nope, not enough 10s to exchange. We only get 1 exchange here. So it looks like the result should be 195. And again, I really do need to note that I'm trading 10 ones for 1 10 because I did have a number jump column. Now, I just want to go over to my other notes where I can use my magic whiteboard. There you go. Okay. So I just want to compare. So I have 15 times 13. And when we take the 5 times the 3, we get 15 ones, which we note as a 1, 1 10, and 5 ones. And so there's the 3 times the 5. And that's not 3 times 1 there. That's really 3 times 10, which is a 30. And then this is really a 10 times 5, which is a 50, thinking about place value. And then 10 times 10 is that 100. So slightly different version of the expanded than, oops, wrong button, no, that one, then I show here. 150, 30, 15. When I look at it in this other version, thinking about 3 times 5 first, 15, 30, 50, 100. So it's still expanded. Putting it all together, we still have 5, oops, 5 ones, 9 tens, 100, 195. Now think about the way you learned eventually to do multiplication. which didn't happen instantly. It was a work in progress. Like you learned in addition to carry, when we think the 15, we write the 5 ones and carry the 110. Now, here's where it gets complicated because then I have to do multiplication and addition together. 3 times 1 is 3, plus 1 is 4. And a lot of kids get confused on that step right there. Which one do I add again? Do I multiply them both? So that is definitely a source of confusion with some kids, especially if there's multiple carries that happen in the multiplication, which happens sometimes. And then, now I'm curious, when you guys learned this, did you learn to put a 0 here, a blank there, or an X?
0.
Most people I've met learn to put a 0 here as a placeholder because we're jumping into the tens column. But in some places, it was taught to leave it blank or to put an X there to mark the spot. The best thing you could possibly do there is put a 0. Right? Because we're multiplying by 10. 10 times 5 is 50, so we need that 0 for the 50 here. And then 1 times 1 is 1. And then adding them up, we get our 195. And one important thing we want to always demonstrate when we're starting out with multiplication of the base 10 blocks with kids to try and illustrate what's going on, that this carry that happens there has to represent a trade with the blocks. So anytime there's a trade with the blocks, it should be a carry. Every time there's a carry, it should be a trade with the blocks. So just to be complete, I'm going to make a note in here, and I'm going to take those groups here and trade 10 ones for 110. So for each of the problems in the activity, I'm looking for a picture of base 10 blocks, whether it's hand-drawn, whether you take a picture of the blocks you have on your desk, or whether you use the online toy here. I need an area that represents it. And then somehow you need to trade and show the expanded algorithm to get the product. All right, go for it.